So for this sprint, we were tasked with doing research related to our upcoming tasks on our project. So we did a lot of research relating to data science techniques on pre-processing data and some machine learning techniques related to training machine learning models. So I'll just quickly go through some of these tasks and what these tasks were, and then I'll go to the deliverables that we have for these tasks. So we did some research on dental charts and intraoral photography. Machine learning team, or excuse me, the machine learning engineering team did some research on SGD gradient descent algorithms, some optimization techniques and algorithms with Atom and Atom W, and some basic schedulers. The data science team wanted to learn to create index and move tensors across devices with PyTorch. Um, the team did some research and getting familiar with machine learning image preprocessing. We had research related to visualizing histogram data for images to determine the effectiveness of different histogram normalization techniques. Um, that's just related to folder changes and naming conventions. Here we had the machine learning team work with researching segmentation models for detecting gum recession as it relates to the project. So here are our code deliverables here, example code related to the task that we've completed for the sprint. So we have a team member here with some image preprocessing scripts and some images here. Here's the code for that. Okay, another team member with some histogram normalization code here. And another one with optimizers in machine learning. There's the images in the code for that. And here is um, this is a code here for the task for tensors and the data set and verification script here. We have deliverable here relating to the machine learning algorithms, the research, and some of the practice code as well. And here is the learning rate schedulers, practice code for that. And some Tensor PyTorch notes and some research and examples for it. We have formatted PyTorch tensors and the notes here with examples. And we have implementation of loading of multiple images in a given directory. And we have example here of segmentation models detecting gum recession. Here is the code for that. And we have implemented data pre-processing example code. And here is image preprocessing research here with the example code from another team member. And we have another image preprocessing research and practice here from another team member. Here's the code, images, and the research. And lastly, we have implementation of configure files, histogram viewing, and image loading.
Work on the preprocessor. There's a config file here that can be used to turn on and off various settings, such as resizing it, as well as the new size for the images, which will be important for standardizing that for training. You can isolate different color channels. We're not sure whether or not we're going to use that yet. Normalizing the image histogram and showing the image histogram when images are displayed is also implemented here. I'm going to show it running quickly. This one on the top here shows that the image resizing works effectively. This is the image and histogram after histogram normalization has occurred. As you can see from this one on the left, it had a very different looking image histogram. And these ones were also isolated to a specific color channel. Looks like we used red for this one. You can also see that it accommodates loading multiple images at once. The way we do that is having the image paths and loading them from there so that we don't have a giant array of goodness knows how many gigabytes of images just sitting in RAM doing nothing. I'm going to show an image histogram as well with isolate color turned off, just so we can get an idea of what that looks like and show that the config file does in fact work. No, we don't need these ones. But as you can see with the color images on, you also get a well normalized image histogram.